All right. Equivalent fractions. First of all, we need to understand what simplest form means. So go ahead and write that down. Those of you who are staring off into space like there's nothing going to happen today. Simplest form is when the numerator and denominator of a fraction have no common factors between them. So when they tell you to put a fraction in simplest form, occasionally they will use the words simplest terms, okay, lowest terms, okay, and they will say reduce. All three of those mean the same thing as simplest form. Okay, so for example, if I have the fraction 32 over 72, okay, 32 over 72 have a common factor. Okay, so what you want to look for is the greatest common factor between 32 and 72.
What does that say at the end if the both terms are common?
Reduce. Okay, so we want to find the greatest common factor of 32 and 72. In other words, we want to find the factor that will go into both 32 and 72, the most, the highest one. One of two ways you can do that. A lot of times you can just see what the greatest common factor is by looking at the two numbers. If you can't do that, then you obviously have to take and do what we talked about last week, and we have to find 32 and 72, and we've got a prime factor, both of them. Okay, the ones that they have in common are those three right there. So 2 times 2 times 2 is what it has in common, which is 8. So the GCF is equal to 8. So that means I can take 32 over 72 and divide it by 8 over 8. 8 goes into 32 4 times. 8 goes into 72 9 times. Is there any common factors between 4 and 9? No. So therefore, that's in lowest terms or simplest form. Okay? Now, the other way you could have done this is to take 32 over 72, and we know that 4 goes into both of them, so we divide it by 4. 4 goes into that, 4 goes into that. 4 goes into 32 8 times, 4 goes into 72 18 times. Well, 8 and 18 have common factors. Common factors would be 2. 2 goes into 8 4 times. 2 goes into 18 9 times. Okay, you will notice in all of these that the fraction that we're dividing by is equal to 1 over 1. Okay, it's equal to 1. When you're making an equivalent fraction, when you create an equivalent fraction, you are simply dividing or multiplying the original fraction by a fraction equal to 1. Okay, and that's what all these are. I'm reducing that fraction by a fraction that is equal to 1. Okay? So I want you to try this one on your own. I want you to reduce or put in simplest form 12 over 35. No, hang on. 28 over 48. Okay, I want you to put that in simplest form. 28 over 48. Okay, raise your hand if you have an answer. Okay, Gabby, what'd you get? 7 over 12. That is correct. Now, to reduce this fraction, we find the greatest common factor between 28 and 48. The greatest common factor between 28 and 48 is 4. So I'm dividing 4 into 28 and 4 into 48. 4 goes into 28 7 times. 4 goes into 48 12 times. There are no common factors between 7 and 12, so therefore that's as low as the fraction can be reduced. Once again, this right here is equal to 1. 4 over 4 is 1. Okay? In other words, I can't do this. I can't take 28 over 48 and divide the top by 7 and the bottom by 12. And divide 7 into that 4 times, 12 into that 4 times. Okay, you can't do that. That is wrong. Because this is not equal to 1. Okay, can't do that. All right, so it has to be equal to 1. Quade?
I did mine 28 over 48 divided by 2.
And did you go further than that?
Yeah, I got 14 over 24. And now I do 7 over.
You can do that. The problem you're going to run into is the more you divide it, the more, it gives you the more options, or gives you the chances of, making a careless error. And so that's why I'm trying to, you can divide it by 2 and then divide it by 2 again. It just means that you might end up making a careless mistake at some point. But yes, you can do that, because 2 times 2 is 4, and that's obviously your what we ended up dividing by. Okay. Now, let's look at a little harder fraction. 30 over 52. Realistically, it's really not that much harder. What is the common factor between 30 and 52, Tristan? 2. So I divide by 2 the top and bottom. Okay, divide it there, divide it there. That gets me 15 over what? 26. Is there a common factor between 15 and 26? No, there's not. So that's your answer. Okay? Do this one on your own. 49 over 105. It can be reduced. Okay, so don't think, oh, it can't be reduced. It can be reduced. Okay, who has an answer? Kennedy, what'd you get? No, not 1 over 5. If it was 1 over 5, that means you'd have to be able to reduce by 49 over 49, which you can't reduce by. Isaiah? 7 over 15. That is correct. Okay. We divide here by 7 over 7. The only factors that 49 has is 7. So we divide 7 into 49, it goes 7 times. 7 into 105 goes 35 times. So your answer is 7 over 35. 15. I was wondering if you'd catch it. It was 15 times. I was wondering if anybody was awake today. All right, now, let's talk about the next thing. I give you the fraction 18 over 21, and I want you to create two equivalent fractions okay. The first way you're going to do that is by simplifying, okay, or reducing. Okay, so that's the first way we're going to create a fraction. So we're going to take 18 over 21 and we're going to reduce it by its greatest common factor. Greatest common factor between 18 and 21 is what? 3. So I'm going to divide by 3 over 3. 3 goes into that 6 times. 3 goes into 21 7 times. No noises, please. If I needed a noise, I'd have a pet. 6 over 7. The second way that we're going to create an equivalent fraction is by multiplying the original fraction by 2 over 2. Now, is 2 over 2 equal to 1? So 2 doesn't go into 2 one time? Okay, so 2 over 2 is equal to 1. So I'm going to take $18 over 21, and I'm going to multiply it by 2 over 2. 18 times 2 is 36. 21 times 2 is 42. So 6/7 and 36 over 42 is my two equivalent fractions for that problem. Each one will be an X. Each one's an answer. Okay, now 2 over 2, understand that I could pick any number. I could say 10 over 10. Or I could say 20 over 20. I could say 100 over 100. It doesn't matter as long as the fraction's equal to 1. For our purposes, we're always going to use 2 over 2 when we're creating an equivalent fraction by multiplying. Because here's why. Tomorrow when we come into class, Quade could have used 3 over 3. Brandon could have used 5 over 5. Jacob could have used 10 over 10. And so now we've got 3 different answers for the second fraction. Okay? To keep that from happening, so I don't have to, hey, coach, is this right? Is this right? Is this right? Instead of answering 18 different questions because 18 people used 18 different fractions to multiply by, we're always going to use 2 over 2. I repeat, we are always going to use 2 over 2 when you're multiplying to create an equivalent fraction. Okay, I've said that now 4 times, so when you come in tomorrow and multiply it by something else, you're going to get it wrong. Okay, now, the other thing that you need to make sure is that you're multiplying the original fraction by 2 over 2, not the reduced fraction. You will notice that I'm not multiplying 2 over 2 to 6 over 7. I'm multiplying 2 over 2 to the original fraction of 18 over 21. Okay, so make sure you use the original fraction in the second answer. Okay, let's look at another one. $84 over 96. Hang on, that's what I want to do in a minute, not that. Uh, 28 over 32. All right, so 28 over 32, they want you to write two equivalent fractions. So fraction number 1, we take 28 over 32 and we reduce it. So 28 over 32 can be reduced by what? No, we've already had this one. Look back in your notes. By 4. So I'm going to divide by 4 over 4. 4 goes into 28 7 times. 4 into 32 8 times. So there's your first fraction, 7 over 8. The second fraction, we're going to take 28 over 32 and multiply it by 2 over 2. Why are you talking? 28 times 2 is 56. 32 times 2, 64. There's your second fraction. So 7 over 8 and 56 over 64. And that's your answer. Okay. I want you to do this one on your own. 25 over 120. I want two equivalent fractions.
What were the numbers?
Don't know.
Which are the two fractions?
Remember, we're looking for the word equivalent or not equivalent. Tristan, what'd you get? Not equivalent. All right, let's see if that is correct. 15 over 36. Tristan, what did you divide 15 over 36 by? By 3. So you divide by 3. 3 into 15 goes 5 times. 3 into 36 goes 12 times. Can't reduce it any further. 40 over 96. What do you reduce by? Huh? 8. So reduce it by 8. 8 goes into 40 5 times. 8 into 96 12 times. So they are equivalent. Okay? Did you not take it far enough down, Tristan? Yeah. Okay, so they are equivalent. Gabby?
What does equivalent mean? Like it matches?
Means they're equal to each other.
So,
For example, if you had a pizza and the pizzas are both larges, let's say you had 2 pizzas and they're both larges, okay? And one of them is divided into 8 slices, one of them is divided into 16 slices. And I give 4 of the slices of one pizza to you, and in the other pizza I give 8 of the 16 slices to Jacob. Okay, Jacob got more slices, but did he get any more pizza? No, because it's still the same size pizza. It still represents 1/2 of the pizza, okay? Now, if it was a different size pizza, that's obviously a different story. But if 2 things are the same, it doesn't matter if you divide one into 4 sections and one into 8 sections or one into 16 sections or any of those, you're still going to end up with the same amount. It's just a different number. So these are fractions that are the same. They just have different numbers on top and bottom. But when you reduce them to their simplest form, then they're either the same or they're not the same. If they're not the same, then they're not equivalent. If they are the same, then they are equivalent. It means it's a fraction. So in other words, if I had 1/2 and 32 over 64, that's an equivalent fraction. Because 1/2, what is half of 64? 32. So 32 over 64, these are equal to each other. Okay? Yep. All right. Your homework. 4.3, 1 through 32. .3, 1 through 32. We still have quite a bit of time left in class. We got about 18 minutes left in class, so do not pack up. No, we got about 8 minutes, yeah. So don't pack up. Get to work.